Wormholes, things of mere science fiction or unobserved natural wonders. Well, right now they're only a theoretical field, but who knows what the future holds. Simply put, a wormhole is a proposed structure that links two places in space-time together and is usually visualized as a giant tunnel linking two wider mouths or entry and exit points. You've probably seen the paper example in various films or demonstrations. When two dots are drawn at opposite ends of the paper is folded in half before someone pierces it, connecting the two dots with the pencil. This example is used in so many movies because it's probably the best and easiest way to show the phenomena. The concept itself links up with Einstein's theory of general relativity, the equations for which account for Schwarzschild wormholes or Einstein-Rosen bridges, which essentially act as massive black holes linking two areas of space-time. The theory suggests that the matter and light that is sucked into a black hole on one end is spat out at the other at a point known as a white hole. This white hole would be located somewhere else in the galaxy, or perhaps even in another dimension. These theoretical wormholes could be utilized for a variety of different things. Some say that they could be used for faster-than-light travel, as part of a far-off future existence when advanced beings can zap between galaxies, with wormholes creating a massive shortcut between any two destinations. Traveling at light speed seems, and currently is, impossible, but we could feasibly travel faster than light using a wormhole. If two massively separated points are connected in this way, it would likely be far faster to travel through the wormhole than it would be for light to conventionally travel between the two locations. Therefore, even though an object is traveling slower than light inside the wormhole itself, it would still reach its destination before a beam of light outside. Others have argued that wormholes could allow for time travel. Theoretical physicist Kip Thorne provides an example in his book Black Holes and Time Warps. As an experiment, Thorne and his wife hold onto two ends of a wormhole. Thorne remains at home with his end while his wife takes hers onto a spaceship that can travel at the speed of light. She shoots into space for 6 hours, turns around, and comes back home, accounting for 12 total hours of light speed travel. The entire time, Thorne and his wife are connected via their wormhole, can see each other, and even hold hands. However, Thorne might struggle to physically greet his wife when she returns from her 12-hour trip because she has traveled at the speed of light and time has slowed on her end of the wormhole. 12 hours for her would equate to about 10 years on Earth. So when she finally lands back on Earth, she'll be 10 years into the future and her husband will be 10 years older. Still with us? We've yet to account for the wormhole itself, though. Thorne's wife, who's now 10 years into the future, can look through her wormhole and see her husband, who's only 12 hours ahead. Therefore, if she were to step into the wormhole, she'd travel 10 years back in time. Similarly, Thorne could theoretically step through his end of the wormhole and travel 10 years into the future. Just blow this up onto an interstellar scale and you have a basic concept of time travel via wormhole. And it's not the only way in which wormhole time travel could be possible either. There are also theories surrounding significant gravitational fields. For example, say we could place one end of a wormhole close to a black hole, which exhibits incredible amounts of gravity and acts to slow down conventional time. The link between that place and somewhere experiencing time as we usually would could provide a means of traveling to or from the future. So that's light speed and time travel ticked off of our ultimate bucket list. Next up, inter-universal travel, or traveling to other dimensions. This theory relies on the many worlds hypothesis, an interpretation of quantum mechanics that posits infinite universes and timelines. According to this idea, every choice or branching path that we, and everything else, refrain from taking in our own timelines exists in an endless list of others. For example, let's say you chose to attend X university instead of Y college because it was closer to home. In this universe, you actually do go to X university, but there also exists a universe wherein you moved away from home to the other college. Now let's say you're in possession of your own personal wormhole similar to Kip Thorne and his wife. Theoretically, if the many worlds interpretation is correct, there would exist countless versions of you with this same wormhole. Therefore, if we could somehow manage to travel between them, we could visit ourselves in different timelines. Of all the options, this is arguably the least likely scenario, primarily because we aren't even sure if the many worlds interpretation has any basis in reality. With that said, these are all least likely scenarios in a way because scientists aren't even sure if wormholes exist. Yes, they exist in theory, but there's no empirical proof that they are there. The entire idea is still far more science fiction than fact. Experts like Stephen Hawking have suggested that wormholes could be all around us, but they're microscopically small, existing within the very fabric of space-time as nothing is completely flat or solid. According to this theory, within every piece of matter, and even in time itself, there exists incredibly implausibly small holes and wrinkles, as in smaller than atoms small. However, because they're so incredibly tiny, we can't ever wish to travel between or manipulate them. In fact, even if conventional wormholes did exist, there'd still be another major problem preventing human travel: their stability. The predicted Einstein-Rosen bridges would simply collapse far too quickly for travel to ever be possible. However, if we introduce some form of as of yet entirely unknown exotic matter into these wormholes, something that exudes negative energy and would expand, then we could potentially prop them open to allow for interstellar journeys. But that's a fairly sizable and completely theoretical if. One current contender for such a force could be dark energy, the largely unknown form of energy responsible for the expansion of the universe. However, we don't currently understand even the basic physics behind dark energy, so rounding it up and manipulating it into opening wormholes which may or may not exist is clearly out of the question. Another potential candidate is something called the Casimir effect, wherein metal plates are used to limit the number of electromagnetic waves at a certain point, creating a so-called negative density which could, at an incredible stretch, be used to stabilize a wormhole. But even the experts tend to agree that this isn't a viable option, as the effect wouldn't be strong enough. And there's one final problem to contend with too, when we consider simply entering the wormhole itself. The extreme densities and energies required to rip open and retain a wormhole aren't likely to create an especially hospitable environment. The extreme conditions needed would almost certainly kill any human who enters it. Unless we've developed some form of indestructible tech to travel in by then, we'd probably be turned into jelly, or something even worse, far before we made it to the other side. For all manner of reasons, wormhole travel of any kind appears impossible for us mere mortals. All in, even if Hawking and co. are right, and wormholes do exist on a beyond microscopic level, we currently have no idea how to identify them, manipulate them, or open them up. And if conventional sci-fi like wormholes are a reality within the reaches of space, they're almost certainly unsuitable for human travel. The laws of physics and biology simply won't allow it. On the plus side, that wormholes theoretically exist is an exciting thought. Sure, there's no definitive or observable proof, and even if there was, we couldn't even attempt to travel through them for a long time. But the possibilities they potentially pose will continue to fuel imaginations for generations to come.